All right, asymptotes and asymptote rule. So we're looking for all of the all important points for all of these rational functions. I'm going to do and explain everything without a calculator. You are welcome to use a calculator on the exam. Just keep in mind if you're taking AP Calc next year, and you should honestly use a calculator on the exam to double check your work and to make sure you're being fast and accurate. But just keep in mind a lot of these things you're going to be doing without a calculator in AP Calc and in regular Calc at least. So you want to make sure that you can do these things. It's a good thing to test yourself before the exam without a calculator. Okay, so x over x squared minus 25. I'm going to factor. Okay, so first, the most important thing here are our vertical asymptotes. We set our denominator equal to 0 for our vertical asymptotes. So those are going to come in here. Maybe I should color code a little bit here, show you where everything is coming from. Our vertical asymptotes are going to come from setting those two equal to 0. So our vertical asymptotes are x equals -5 and x equals +5. Our horizontal asymptote comes from the relationship between the top and the bottom. This is a bottom-heavy fraction. Since this is a bottom-heavy fraction, our horizontal asymptote is y equals 0. Every time. You have more x's on bottom than you do on top, and here we have 2 x's on the bottom, x squared on the bottom, and an x on the top. That's a bottom-heavy fraction, and your asymptote, horizontal asymptote, is always at y equals 0. Awesome. All right. Next, X-Intercept. Our X-Intercept comes from setting any variable on the top equal to 0. So here our X-Intercept is going to be at 0, 0. And luckily with this one, that makes our Y-intercept 0, 0 as well. Kind of double bonus. Anytime one of your X-intercepts is 0, your Y-intercept is going to be 0 as well. All right, so I'm going to check off what we have so far. Intercepts. No removable discontinuities on this one, since we don't have anything cancelable. We have horizontal and vertical asymptotes. No oblique. Remember, oblique asymptotes only occur instead of a horizontal. Oblique is kind of a special kind of horizontal asymptote. The last thing we need is the domain and the range. So here, our domain is all reals, but we x cannot equal -5 and 5. So -infinity to -5, -5 to 5, and 5 to infinity. And range, -infinity to 0, 0 to infinity. All right, let's look at another example. More factoring to be done with this example. In the numerator, first I can take out a 2, and then I'm left with x squared minus 1. And then I can do difference of squares on x squared minus 1. X minus 1, x plus 1. And I always do all of the factoring and canceling before I start doing any of the other math. In the denominator, I need to factor to multiply to 6 and add to -7. So that's going to be x minus 1 and x minus 6. -6 and -1, add to -7 and multiply to +6. All right, so vertical asymptotes. And actually, maybe before we talk vertical and horizontal asymptotes, we should talk a little about the removable discontinuity that's happening here and get it kind of out of the way. The removable discontinuity is going to come from this cancelable binomial. So our removable discontinuity, or hole in our graph, we set that equal to 0. We move our 1 over so it's positive. Our x is 1, and we can come back and find our y later. You can absolutely enter the equation without your x minus 1 into your calculator and get that. The other way you can get this piece is to use the canceled fraction. Again, I said you can use the canceled fraction in your calculator. You can also just do that calculation by hand. So here's my canceled function. I'm going to put 1 into it. So in my numerator, 1 plus 1 is 2, so 2 times 2 is 4. And in the denominator, that is a negative 5. So my y value when x equals 1 is negative 4/5. And we got some extra practice with that in our limits unit. So that should be pretty fresh in your mind, how to find the y value as our removable discontinuity. Okay, but we're still going to exclude our removable discontinuity from our domain and our range. Okay, back to vertical asymptotes. So x minus 1 has already been used. We're not going to use that when we're looking for vertical asymptotes. Our vertical asymptote is going to be here, x minus 6 equals 0, so that means x equals our vertical asymptote. Horizontal asymptote, since we have the same degree, we're going to take the ratio of our leading coefficients. So this would be 2 over 1. So our horizontal asymptote is y equals 2. Our x-intercepts and y-intercepts you can always get from your graphing calculator. X-intercepts here, we're going to set our whatever piece of our numerator with a within variable is left is going to be where our x-intercept comes from. So x plus 1. And that means that our x-intercept is negative 1, 0. Let me find another color to use. Y-intercepts. We actually need to find our y-intercepts this time. If you have this already put in your calculator, you can go to your table. You can also just hit trace. And usually, if you haven't messed with any of your settings, if you hit trace on the 84 on your calculator, on your graphing screen, your calculator trace will pull up the y-intercept first. You can also get the y-intercept from putting 0 in for x. So on top, that gives me 2 times negative 1 times 1. In the denominator, that gives me negative 1 times negative 6. So that makes my y-intercept negative 2 over 6, which is 1/3. Negative 1/3. Last piece is domain and range. So for domain, we're going to exclude our vertical asymptote and the x value of our removable discontinuity. So negative infinity to 1, 1 to 6, 6 to infinity. For our range, we're going to exclude our horizontal asymptote and the y value of our removable discontinuity. So negative infinity to negative 4/5, negative 4/5 to 2, 2 to infinity. All right, two more problems down. Nice work.